When Tom Mitz told me what he was thinking of, a project to decode the molecular universe, I had one of those moments when you know you've heard an important idea, but simultaneously wonder why you hadn't heard about it many times before, because it seems so obvious. But that's one of the characteristics of important ideas. They often become obvious only after an unusually perceptive person has called them to our attention. So thank you for inviting me to a workshop that I expect will be a first step toward implementing a transformative idea. 35 years ago, we embarked on developing a related idea, the Human Genome Project. What I'd like to do is review its origins, how and why it took root at DOE and evolved into an international project, the agents that supported and opposed it, and most were in the latter category, at least at the beginning, and the complicated process by which the idea was converted into policy. But I'll leave it to you to decide if there are lessons that can be applied to the present situation. The proposal to sequence the human genome came as a double trauma to the large majority of the biomedical community. First, a seemingly biological idea, and I say seemingly for a reason which I'll explain shortly. A seemingly biological idea came from neither NIH nor NSF. It originated at an odd place, at an organization whose budget was dominated by high-energy physics and national defense, and what I'm going to say next was important politically because it was another source of resistance. It came from an agency that was seen by many as having a very poor environmental health and safety record. It was not just a strange place, but a place disdained by many congressmen, and that attitude spilled over and had to be explicitly confronted as we moved to launch the project. So there was a good deal of grousing across a broad swath of Congress and the academic community. In fact, one well-known academic referred to the proposal as a project for unemployed bomb makers. Then there was another source of anxiety. The Germans have a word for it, Torschlusspanik, literally a fear that the gates are about to close. In this case, panic over the possibility that because of the substantial costs of such a project, the sluice gates that control the flow of funds for NIH investigator-initiated research would slam shut, stranding young investigators and thereby stunting the growth of U.S. biomedical science, diminishing our leadership in the world, and ultimately the quality of health care. So it was seen as a potentially major perturbation caused by a bad idea from a place that wasn't even qualified to raise it. But it was an idea whose time had come. How does an idea whose time is at hand become policy when the responsible agency, namely NIH, isn't psychologically, managerially, or scientifically prepared to adopt it, and isn't even united in the belief that it's important? In fact, there was a distinct belief that it would do more harm than good. But those views notwithstanding, the proposal to sequence was thrust on the public agenda, and the first question is, why DOE? The great 19th century chemist Louis Pasteur was once told that he was just lucky to have stumbled upon the technique of vaccination, and Pasteur's response was, chance favors the prepared mind. And in fact, it also favors the prepared organization. The fact that DOE, as a physics organization, had the technological and managerial culture in which large, complex projects could take root was a good part of the reason the Genome Project was initiated there. The third slide summarizes some of the elements of that culture. It had data management, computation and analysis, and innovative engineering. It was familiar with all those things, an expert in all those things. It had public-private partnerships, international cooperation, large multidisciplinary consortia, MOUs between federal agencies. These are all things that the Genome Project seems to have taught the biomedical science community, But they were all things known to the physical science community and all things in which the physical science community already had experience. And perhaps most important is this last bullet. It had leadership that was at home with the idea of large, complex projects and was not risk averse. So the DOE culture was fertile soil. DO operations were well oiled. And let me say what I mean by that. I'll start by saying something about three of the main players. The first and most important, I think, is David Smith, who was director of the Health Effects Division, Office of Health and Environmental Research. David really is an unsung hero. He was with me from the very beginning. Without his cooperation, I don't know what would have happened. I described this actually in my memoirs. Interestingly enough, when I was writing them, I wrote to David. I asked him if he had some material. And one of the things he said to me is, he said, I'm struggling to remember what I did. Not that he lost his memory. He had good memory. But he didn't see himself as playing a major role. The fact is, he played a major role, and he hasn't been appropriately recognized for it. So that kind of gives you a hint to what things were like within the Office of Health and Environmental Research. The office is now called the Biological and Energy Research. But the office functioned very, very smoothly, and it was a large part due to outstanding leadership by the division directors. I reported to Alvin Trivelpiece, who was director of the Office of Energy Research, essentially the Assistant Secretary for Energy Research, but maybe more importantly, he was science advisor to the Office of the Secretary, so he had a lot of clout. Al was heavily involved in the SSC at the time. There was no budget flexibility. The superconductor supercollider was an absolute priority. It wasn't in safe harbor, and in fact, it never really got to safe harbor, unfortunately, for the physics community. But he gave tremendous moral support, and in particular, he went to William Flynn Martin, who was the Deputy Secretary of Energy, with whom he worked. And Martin, who was an MIT-trained economist, understood it right away. Both Al and Martin understood the importance of this project really amazingly quickly. And what was especially impressive to me, and I think this is absent all too frequently from senior administrators, they were both genuinely interested in the science that it would support. In fact, about 5 years ago, this really made me feel good. In a brief email exchange I had with William Flynn Martin, he described the Genome Project as one of the two mighty achievements of the Reagan administration, the other being Reagan's role in the demise of the Soviet Union. So there was real cohesion within the Department of Energy. There was real support morally, if not budgetarily. But of course, to move this forward, we needed more than just the Department of Energy. So there was cohesive support within the Department of Energy. Then there was the White House Office of Science and Technology Policy. I was in my position because I was nominated by that office, but it showed no interest in the Human Genome Project. That might seem somewhat ironical, but what happened is Jay Keyworth, who was director when I joined DOE, left OSTP, I think over a feud about Star Wars, and the person who replaced him was a double E who didn't know anything about genomics. There was no telling what could have happened if Jay had remained in place, but as Linus Pauling once said, it's difficult enough to follow real-world lines, let alone those based on imagination. Then there was the much-feared Office of Management and Budget. The Jabberwocky is what we would call it. It would snap off your head as easily as it would cut the budget. We expected resistance from them, and the House of Representatives. We also expected resistance from them, and we got plenty of that. Then there was the Senate. I had no idea what was going to happen there. The private sector, I had no idea. The scientific community didn't know about it yet. This was at the very, very beginning, and of course I had no idea how it would take there. So because we had no idea of how the scientific community would react, we called a workshop in Santa Fe, the Santa Fe workshop, and invited about 40 to 50 leading human geneticists and molecular geneticists. We also invited, and this is important because it gives an idea of what the situation was like at the time, culturally, sociologically, We invited representatives from at least 6 or 7 federal agencies, the EPA, a couple of NIH institutes, NSF, the Department of Defense, and the response was striking. There was essentially no response. We got one response, which was regrets. I think most people had no idea what this was about. In fact, it appeared that in the eyes of most senior scientific administrators, the thought of a massive sequencing effort didn't even rise to the level of what we say in New York, mishigas, craziness. I recall the words attributed to the physicist Wolfgang Pauli, who remarked on reading a student's paper, "This isn't right, it's not even wrong." Or maybe the reaction was more like Dave Bowman's in Kubrick's 2001. To Bowman, alien life was not just strange, it was entirely unrecognizable. It made absolutely no sense. And so too, a massive sequencing project, it had the bizarre, incomprehensible form of a Kubrick alien. So it quickly became clear that education was needed, and then after it was explained and understood, the outrage had to be contained. The picture that was beginning to emerge after the Santa Fe workshop was that there was some strong support within the scientific community, and there was also equally strong opposition within the community. I remember a colleague quipping about the difference between the biological and physical communities and how they react to new ideas. The story was that physicists, when they were under attack, would form their wagons in a circle and fire outward, whereas biologists would form their wagons in a circle and fire inward. The community seemed to be doing both. The agencies, some were for, some were against. Most were still trying to assimilate what was going on. The same is true of some of the private sector. But beyond that, one of the serious unknowns was how the Congress, both the Senate and the House, was going to respond. It started to become clear to me at the time, from conversations I had with some congressional staff, that the House of Representatives, and this was a Democratic House in a Republican administration, was very dissatisfied with the Department of Energy's health and environmental safety record. But politics aside, there was substance to some of those concerns. However, those of us trying to get the Genome Project off the ground paid a price for this. But it was a price that was based on confusion about lines of responsibility at the Department of Energy. I was Director of Health and Environmental Research. On the other hand, there was another whole secretariat that was responsible for environmental health and safety. I was responsible for research. The secretariat was responsible for regulatory problems and for the actual health and safety and contamination and conditions at the laboratory. Two entirely separate spheres of responsibility. But they were confused. Beyond that, I had myself very strong feelings about potential environmental problems. And in fact, I was very concerned about accepting a position at DOE for exactly that reason. I was also a Democrat, but the House staffers that were opposed to what we were doing knew nothing about that, knew nothing about my position, and confused it with environmental health and safety. One of the things that happened is that I reacted to some of the reports I was hearing about Oak Ridge, including reports of an increased incidence of certain types of cancers. And I started to wonder what was going on. The typical response was that the types of cancers that were elevated were not the types that would be associated with radiation. In any case, I felt strongly enough that I decided to make a trip to Oak Ridge to visit and to speak with the unions. That was something I clearly should not have been doing. And I have to say that I myself wasn't fully attuned to the division of responsibilities. In any case, I made the trip to Oak Ridge, listened to what the unions had to say, came back, spoke to Trivial Peace. Trivial Peace was taken aback that I went to Oak Ridge, and he let me know it, but there were no real consequences. Actually, there was a consequence, and it happened to be a very beneficial consequence. My credibility with some of the House staffers shot up. That is to say, After they found out that I had a strong interest in what was going on and that I made that trip and I spoke to people, they began to believe that maybe things weren't what they thought they were, at least with respect to the office that I was directing. So the resistance from the House subsided after that. And that may or may not, I don't know what the reason was, but I'm pretty sure that was part of it. At least that was some of the feedback I got from our public relations office. In addition, we also received some really unexpected and crucial support. First, support from someone we call St. Pete, Senator Pete Domenici, who was another unsung hero. He gets very little credit, but I don't think we would have gotten very far without his support. Domenici, I wasn't supposed to be talking to the Senate, certainly to senators. I would speak to staff, some staff, mostly the House. Domenici contacted me directly and wanted to speak with me, and so I met with him. And we developed a good rapport, and in fact, we developed a friendship that lasted until 2 weeks before he died. That was the last time I spoke with him. So Pete deserves a tremendous, tremendous amount of credit. And then, really surprisingly, the Office of Management and Budget. Judy Bostock was the OHER budget examiner, the Office of Health and Environmental Research budget examiner. She's a person I had to speak with. And Judy actually suggested that I speak with her boss, Tom Palmieri, which I did. I was surprised that she made that suggestion. She was perfectly happy for me to speak to the person she was reporting to. And Tom turned out to be supportive. He liked the idea. What he liked about the idea is that it really wasn't an open-ended scientific project. And this was a source of tremendous misunderstanding by the community. He saw it right away. I presented it as an engineering project whose goal was to create an infrastructure that would support science. It was a project that had a beginning, a middle, and an end, and something he could grapple with. And so he was supportive, and he alerted me to where some of the landmines might be. You know, he was very, very strong on my reaching out to the scientific community and make sure we had broad support. So those are two very important sources of support as we move forward with this. The scientific community, however, had serious concerns. And by the scientific community, I mean the NIH constituency. At first, they were concerned about a loss of funding for investigated or initiated research. I have to say that they didn't know that they would lose any funding because this hadn't been presented to Congress yet in any substantial way. So they had no idea. No one had any idea how Congress was ultimately going to come down on this. Although things were taking shape, opposition in the House, some interest in the Senate. There was concern about biomedical science becoming overly political in the sense that NASA was, for example. And then there was also talk that it was just bad science. NIH had an advisory process. They had a lot of money already being spent, hundreds of millions of dollars on sequencing. And sequencing should be directed at understanding specific regions of DNA and proteins. Well, in fact, it wasn't science. It was an infrastructure project, and it was an effort to develop a reference sequence. And that idea seemed to have slipped by the community for whatever reason. One of the remarkable aspects of all this, I think, was the speed with which everything was pretty much resolved between the time we started it in early 1986 and 1990, late 1990. Tremendous amount had been accomplished in terms of coordination and smoothing out whatever difficulties there were initially. And a lot of that had to do with congressional mandates. There was going to be no money unless the relevant agencies, predominantly NIH and DOE, began working things out. So everything worked out pretty well. I think it's clear that any project which is new, which introduces a new idea, has to be prepared for some resistance. And in the case of the Human Genome Project, the origins of pushback were the unexpected origin. And I think we need to remain open to things coming from unexpected places. and the possible disruption of investigator-initiated research. And then what I haven't discussed are the complex ethical and legal issues. Now, the first of these, there was no idea of how to respond to a proposal from a strange place that was apparently unqualified, and it took time to develop some psychological ease with that, and also to arrange smooth operations between the different agencies. The second, disrupting investigator-initiated research, was a red herring, but nevertheless loomed large. And in the third, the Department of Energy really led the way. We had developed a legal and ethical, I wouldn't call it a mandate, but certainly a policy to provide some 3% to 4% of the budget to study legal and ethical problems. And that was done in the spring of 1987, a few months before I left the Department of Energy. The next important event in the story occurred in the fall of 1987, shortly after Jim Watson arrived at NIH. At a congressional hearing, Watson announced a plan to study ethical and legal implications of the project. Al Gore then turned to the acting head of OHER and asked what DOE was doing. My successor replied that he decided to leave such studies to NIH. That unfortunate response transformed OHER in the eyes of Congress from being a leader to being a resistant follower. It's a reminder of how a well-intentioned, albeit short-sighted policy can instantly rub out long-sought, hard-won gains. Returning now to the theme of convergence between chance and preparation, it should be more or less obvious that it not only favors the prepared mind and the prepared organization, it also favors the prepared nation. And preparation means in part that the nation needs to stay open to ideas with potentially high benefit-risk ratio, regardless of the origin, with a rigorous vetting system. New information along with powerful methods for analyzing it will almost invariably lead to major discoveries. The HGP was perhaps a prime example of this. And in fact, given the AI methods now, I think we're going to see a tremendous amount happen. Cooperation is important, but so too is competition. US-Japan competition was important. Solera, the federal government competition, was important. But of course, it shouldn't diminish the will to do things cooperatively, to collaborate. The extraordinary time compression inherent in the exponential rate of technology development very often leads us to seriously underestimate the rate of technological innovation and cost reduction. And that really is important. We overestimated the cost of the project. Actually, in a way, we didn't. I remember Dave Smith wrote a letter about this to Science, and the costs were $3 billion, and he said, no, they're not going to be $3 billion. We're going to be developing new technology. We need to take that into account. And as it turned out, he was right. The cost was considerably less than that. It was a third of that at most. So accurate budgetary projections are important, and the rate of technological development feeds into that. What can we expect in the future in very, very broad outline? The rate at which new discoveries enter the clinic should continue to accelerate. In fact, I think the acceleration will increase. And in a large part, that's because of a deeper understanding of the cell and the availability of these incredibly miraculous computational technologies that have burst upon the scene in the last several years. That's going to also play a major, major role, probably the greatest role, in fact. And then a much more general awareness of the importance of what I call the agricultural trifecta. And I think that's going to have a strong focus from the outset. It's going to impact climate change, it's going to impact crop yield, and it's going to result in new medicines, depending upon how we go about supporting agriculture. But the opportunities there and the impact is potentially enormous, and I'm really looking forward to watching that happen. Thank you all very much. It's been an honor to participate.